Hi, my name's Jessica Budai, and I will be presenting to you guys about the cell process capacity improvement. In my presentation, I'll cover why it shows cellular manufacturing, the theory of constraints application in the real world, value stream mapping, and then financial metrics applicable to operations. As discussed in one of our teaching notes in Module 5, the theory of constraints is a methodology for identifying the most important limiting factor that stands in the way of achieving a goal, and then systematically improving that constraint until it is no longer the limiting factor. Identifying constraints can be used to understand where there might be gaps in a process which assist in improving product flow. All manufacturing companies rely on material throughput in order to maintain a strong business. The specific areas of the theory of constraint that I found most impactful are understanding your bottlenecks, identifying your longest lead time item, and improving throughput in order to meet demand. Bottlenecks are a very important metric for many manufacturing facilities as they directly impact the amount of material that can make it through a production process. It's important to review what specific products are going to be analyzed in the process in order to ensure the data gathered is consistent with the results being sought after. Lastly, process throughput helps to identify what the available capacity is within the process in order to understand if a process can meet the customer's demand. This leads us to value stream mapping. Value stream mapping details, which I'm specifically going to focus on, are understanding all the steps within a process, identifying the value added versus the non-value added steps, and identifying areas of improvement. Typically, when a map is completed, the number of steps and decision points are captured and analyzed. This helps us identify which steps add value to the process and which do not. Specifically to the customer, these are analyzed. Typically, we'll ask ourselves, is the customer willing to pay for that? If the answer is no, then most likely that step is considered a non-value added step. It is in this process as well where you want to analyze all of the decision points. In an optimal future state process, we learn from our class notes, we do not want any decision points. If there are decision points in a process, that opens the door to potential errors being made. By combining both of these analyses conducted on the process steps and decision points, we can draw a conclusion on where the current bottlenecks and process breakdown points occur. It is at these points we want to see if there is room for improvement. The more waste that can be eliminated from a process, the more throughput that process can put out. This brings us to the financial metrics of operations. The financial metrics specific to cell capacity and flow are productivity and then revenue per square foot. Productivity is a critical metric in the manufacturing industry as it measures the ratio of outputs to inputs in a production process. For example, if a machining company was to produce 3 pipes per day and due to cell realignment and some additional process changes, they now are able to produce 10 pieces per shift, then they increase their productivity by 7 pieces. Obviously, any manufacturer wants their productivity to be absolutely as high as possible. The second critical metric that ties into operations financial impact is the revenue per square foot. This metric ties directly into productivity as well. If a company can produce the same number of components in a smaller square footage of space, then they are in turn increasing their revenue per square foot. Overall, a company wants to have continuous improvement. As a manufacturing process within any business or industry will continue to evolve, it's important that these companies complete their analysis more than once. As discussed earlier in my presentation, identifying capacity constraints within a process is critical to improvement of a process. In our teaching notes on the theory of constraints, we learn that once a bottleneck has been removed, another one arises. Continuous improvement is a never-ending process, and in order for companies to remain profitable and competitive, it is really important for them to always strive to improve. Overall, this brings me to my conclusion. Understanding capacity constraints is a critical factor when operating a manufacturing facility. Some critical things learned throughout this course is the first analysis is never the last. Continual review and analysis are a valuable part of conducting a business and they are key to its future success. Understanding where your bottleneck exists is always a key characteristic when looking at process capacity. The operations team must review their current and historical trends in order to identify the next areas for improvement. Secondly, it is in order to establish an extremely productive process which optimizes its flow to the maximum capacity, the operations team must eliminate as many decision points as possible. Removing decision points helps streamline a process. And finally, in order to optimize throughput, you must capitalize on both the previous 2 points I made, and the combination of these factors will help lead to increased revenue and decrease in costs for the company as a whole.